So today we get to do questions on density. My name is Arnold Rangakuramia and this is Kisembo Academy. So we'll get started with the very first question. The diagram shows an experiment to find the density of a liquid. What is the density of a liquid? Now, first of all, formula for density, we know that density is given by mass over volume. So what is the mass? Now, we're looking at for the density of the liquid, so we need to find the mass of the liquid. Looking at this closely, you find that this liquid at first is being measured. This liquid is in this measuring cylinder, and the measurement is being done on a balance right there. Now, before the liquid was filled into this measuring cylinder, the balance read 200 grams. And then after the liquid was filled, the balance reads 250 grams. So the difference between these two figures is going to tell us the weight of the liquid. So the mass of the liquid. So the mass of the liquid is simply going to be 250 minus 200. When we subtract those two, we end up with 50 grams. So meaning that the mass here is 50 grams. Divide that by the volume. The volume here is we have 510. If I'm to pull that up close, then we have this is 15, 20, then 25. This is 25, 25, 30, and so on. So the reading there is 25, and the units are centimeters cubed. So here our calculation is divide that by 25. 25 centimeters cubed. And so you find that 50 divided by 25 is going to give us 2 grams per centimeters cubed. Sometimes it's written as 2 grams centimeters to the power negative 3. The negative is what is representing that, the power. So from that, the answer we have here is B. A metal block has the dimensions shown. It has a mass of 1000 grams. So what's the density of the metal? Again, we know density. Sometimes density, we can simply say density is equal to mass over volume. This symbol for density sometimes is represented by rho. So sometimes I will be writing that rho, which means density, is given by mass over volume. So if I use rho and d interchangeably, I'm meaning density. So that's going to be equal to the mass. Now the mass here, they're telling us it's 1000 grams. So it's going to be 1000 grams. Divide that by the volume. So we'll need to find the volume of this. Now from here, we can say that of course the volume of a cube like this, the formula for volume here is given by length times width times height. Let's call this our length. So that's our length. Let's call this our width. That is our width. And let's call this portion our height. So our length here is 10. Multiply that by our width, which is 5. Multiply that by our height, which is 2. And if I can bring this here up there, it's going to be 10 times 5 times 2. Now, if you look at the nature of our answers here in the objective questions, they are not exactly split up into one digit as the final answer. This is all in centimeters cubed, yeah. So this is going to become it's going to become 1000. Divide that by 10 times 5. So when you look at this and all these answers here, which one resembles this? So if you see this is 10 times 5 times 2, you realize that this answer we have here looks like that. 10 times 5 times 2 grams per centimeters cubed. So our answer here is D. So here we go with question 3. A student wishes to determine the density of a solid block shown. What quantities must be known? Of course, when we are looking for density, the quantities that need to be known are mass and volume. So let's look for those quantities here. Do we need the area of the shaded face and the volume of the block? Does that give us density? If you see the area of the shaded block, of the shaded face, and the volume of the block, yes, we will have the volume, but mass, the area of the shaded face does not help us get the mass, so this can't be it. Then you have the area of the shaded face and the weight of the block. Now, the area of the shaded face cannot help us find the density. We need something giving us mass and volume. So this is not it. Then we have the mass of the block and the weight of the block. Well, the mass of the block will help us find that, but the height of the block is not enough to help us get the volume. So this is also out. Then here part D, they are saying the mass of the block and the volume of the block. Just like you said, the mass of the block, it is right there, and then the volume of the block, it is right there as well. So the answer is D. That's question 3. Moving on to the next one. Two cylinders are made of the same metal. Both cylinders have the same cross-sectional area, but one is longer than the other. What quantity is the same for both cylinders? Density. Of course, density, if this is copper and this is copper, their density will be the same. Density is the mass per unit volume of a substance. So the density of, if they are saying that they are of the same metal, meaning the same material, yeah, their densities will be the same. The answer here is A. Their mass can't be the same because mass is the quantity of matter in a substance. The quantity of matter in cylinder A is way less than the quantity of matter in cylinder 2, since cylinder 2 is bigger, is longer. So the mass can't be the same. The resistance, well, this is something to do with electricity. Resistance is affected by the length of a conductor. If this was a conductor, the longer the conductor, the higher the resistance. We shall explain this better in electricity as a topic. So the resistance also can't be the same. Then we have the volume. Well, of course, volume is a space occupied by an object. This cylinder 2 clearly occupies more space than cylinder 1, meaning their volumes can't be the same. Moving on, next, the mass of a piece of metal is 1,200 grams. A measuring cylinder contains 150 centimeters cubed of water. The piece of metal is put into the measuring cylinder. The water level rises to 250 centimeters cubed and covers the metal. What is the density of the metal? Of course, we all know that density is given by mass over volume. Now let's try and do this in a diagram here just to simplify it. First, they are saying that a piece of metal is 1,200 grams. So we already know the mass. The mass here is 1,200 grams. Divide that by the volume. Now we need to find the volume. Now the volume is being determined using a measuring cylinder, and they're telling us here that a measuring cylinder contains 150 centimeters cubed of water. So at first this thing had 150 cc of water, and then the piece of metal was dropped there and it was submerged, and it is submerged, the water rises to how much? They're saying that the piece of metal is put into the measuring cylinder, the water level rises to 250, so it measures to 250 cc and covers the metal. What's the density of the metal? So if the water was at first was like this, then you put in this piece of metal and the water rises to 250 cc, it means it was able to rise because you submerged that piece of metal. So the difference or the rise in the water level is because of the volume of the metal. So the volume of the metal here is going to be given by 250, which is the new level of the water, minus 150. When we subtract those two, we end up with 100. So this is going to be out of 100. That's the volume of the piece of metal. And then we shall end up with, this goes with that, this goes with that, we end up with 12. This 100 is in centimeters cubed, or cc, so it's 12 grams per centimeters cubed. And from there, we are able to see that our answer is D. A person measures the length, width, height, and mass of a metal block with rectangular sides. Okay. Which of these measurements must be used in order to calculate the density of the metal? Again, we know that density is mass over volume. So we need the mass. So we need the mass So meaning, but also we need the volume. So mass only won't help us to find the density, so this is out. Height and mass only, yes, we need the mass, but height only cannot help us to find the volume, so this is out. Length, width, and height only. Length, width, and height only helps us to find the volume, but it won't help us to find the mass of the object, so this is also out. Then here we have length, width, height, and mass. So length, width, and height will help us find the volume. Then plus the mass, we plug in into this and we are able to get the density. Our answer here is D. Moving on to number 7. A liquid has a volume of 100 centimeters cubed and a mass of 85 grams. The density of water is 1 gram per centimeters cubed. How does the density of the liquid compare with the density of water? So we have the density of water as 1 gram per centimeters cubed. So the liquid, we have to find the density of the liquid. So we shall say the density of the liquid is going to be given by the mass of the liquid, divide that by the volume of the liquid. What is the mass of the liquid? The mass of the liquid, the question says, is 85 grams. So we have 85 grams, divide that by the volume of the liquid, which is 100 centimeters cubed. So that's going to be 100 centimeters cubed. This is 85 grams. And when we divide the two, we end up with 0.85 grams per centimeters cubed. Now, if you look at 0.85 grams as the density of the liquid, you find that the density of water is higher. So they're saying, how does the density of the liquid compare with the density of water? A, its density is higher than that of water. Is that true? No, it's not. Its density is lower than that of water. Is that true? Yes. We see that the density of the liquid here is lower than the density of this liquid, which is 0.85, is lower than the density of water, which is 1 gram per cc. So B is correct. Let's look at other objectives. Its density is the same as that of water. Nope. It is impossible to say with only this data. It is possible to say with the data. So the answer is B. The table gives the volumes and masses of 4 objects. Which object has the greatest density? So we are going to go ahead and calculate each one of these, and we should be able to find out which one has the greatest density. Again, we know that density is given by mass over volume. So we shall start with A. So density of A is given by the mass, which is 5.4 grams. Divide that by volume, which is 2. What do we end up with? We have density of B giving us the mass, which is 13, over volume, which is 3, and we end up with 4.3. We have the density of C, which is given by, mass, which is 15. Divide that by the volume, which is 6, and we shall end up with 5. Then we have the density of D, which is 18 right there. Divide that by 5, we end up with 3.6. So all these are in grams per cc. So the question says, which object has the greatest density? Of course, here it is B. So our answer here is going to be B. So the diagram shows the dimensions of a rectangular block of metal of mass M, as you can see. Which expression is used to calculate the density of the metal? We know that density is given by mass over volume. So they're saying the mass is M, so definitely mass is going to be M. Divide that by volume. Now volume is given by length times width times the height. The length here is P, so volume is P times the width, which is Q. This length is Q. Multiply that by the height, which is h right here, which is h. This is also the height, which is r. So you find that this expression is equivalent to this PQR, m over PQR. So that's the expression used to calculate the density of the metal, and our answer here is D. Moving on to question 10, diagram 1 shows an empty measuring cylinder on a balance right there. Diagram 2 shows the same measuring cylinder on the balance, but it now contains a liquid. What is the density of the liquid? We know that density is given by mass over volume. What is mass? So the mass of the liquid, we shall determine that from the balance here, Before we put in the liquid, the measuring cylinder was 30 grams. And now when we put in the liquid, the balance reads 50 grams. So meaning the balance, the reading on the balance was able to rise because of the liquid that was put there. So to get the mass of the liquid, we find the difference between these two figures. We get the reading of the balance after the liquid has been put, which is 50 grams, minus the reading of the balance before the liquid was put, which is 30 grams. That is more like you're subtracting off the weight, the mass of the measuring cylinder. 50 minus 30 gives us 20 grams. So that is the mass of the liquid. So the mass of the liquid is 20 grams. Divide that by the volume. So the volume, from what we need to read this off from the measuring cylinder here. So we know that this is 2 right there. 2, 4, 6, 8, it's 10. So it's 10 and the units are centimeters cubed. So the volume here is 10 centimeters cubed. So you find that the answer is 2 grams per cc, or grams per centimeters cubed. And so our answer is 2 grams per centimeters cubed. Our answer is C. 4 rectangular blocks P, Q, R, and S are shown. Each block is labeled with its size and its mass. Okay, which two blocks have the same density? So for us to be able to determine which two blocks have the same density, we are supposed to calculate the density of each block. So we'll get to it. So we have block P right there. So the density of block P is given by definitely mass over volume. So what's the mass of block P? That's going to give us 10 grams. Divide that by the volume. Now volume is length times width times height. That will be our length, this will be our width, that will be our height. So which is 2 times 2 times 2. Now that is 2 times 2 times 2, and that is going to give us, let's 10 over 8 grams per cc. Let's leave it like that. That's the density of P. So let's look at the density of Q. So we shall go ahead and set density of Q. The density of Q, still again, is given by mass over volume. This is going to be, the mass of this is 10 grams again. So it's going to become 10 grams. Divide that by the volume. The volume, we have length, we have the width, we have the height. The height here is 2 centimeters also. So this is going to become 3 times 2 times 2. So 3 times 2 times 2. So 10 grams, this is going to become 10 divided by 3 times 2 is 6. 6 times 2 is 12. That is grams per cc. Let's first leave it like that. We are only trying to look for blocks with the same density. So if we have the same expressions here, that'll be it. Okay, that's the density of Q. Then let's go ahead and find the density of, R. The density of R is going to give us mass over volume. Okay, the mass of R is 20 grams. So that's going to give us 20 grams. Divide that by the volume. This is the length, that is the width, that is the height. Length is 4 times 2. That is times 2, and then times 2 also. So we shall end up with 20 divided by 4 times 2, 8. 8 times 2 is 16. That's the density of R. Then we have the density of S. Density of S still is given by mass over volume. That's going to give us the mass, which is 20 grams. So we shall say that is 20 grams. Divide that by the volume, which is length times width times height, which is 2 times 2 times 2. And we shall end up there with 20. Divide that by 2 times 2 is 4. 4 times 2 is 8. So from there, we have 4 answers here. Which two are the same? The question says which two blocks have the same density? Okay, our fractions are not the same, but I think we can go ahead and simplify them further. From here, I think if I simplify this by 20 by 2, 10 by 2, 8. So this reduces to 10 over 8. And if you realize that this 10 over 8 is the same as that 10 over 8 right there. Okay, the thing is you can also still go ahead and calculate this 10 divided by 8, you reduce it further, you get your final answer, and then when you get the two final answers that are the same, well, that's the answer, I mean, to this. So in this case, we are able to see that P and R are having the same densities. So our answer here is the answer that says P and R. Our answer is B. Next, a student is given 4 different objects and a meter rule. Each object has a known mass. She is asked to determine the densities of the metals from which the 4 objects are made. The objects are copper cylinder, a glass cube, a steel spanner, and a stone tile. Using only the meter rule, she is able to find the densities of only 3 of the 4 metals. Which are these metals? Of course, like I said, density is given by mass over volume. Now, the issue of mass is known. The question says that each object has a known mass. So we know the mass. So the mass issue is sorted. However, you've been given a meter rule, and of course, if you're to get density, you need to know the volume. So the question is that using a meter rule only, what is she able to find? As in, she is able to find densities of only 3 materials. What are these 3 materials? So we need to look at a material where we can only find the volume using a meter rule. Of course, for you to be able to find the volume using a meter rule, it means you're supposed to be able to use it to measure the dimensions you need. So for example, if you look at this glass cube, if you use a meter rule, you can use it to measure the length, you can use it to measure the width and the height. When you do so, you're able to get the volume. So she's able to find the volume of this. Then looking at the copper, to get the volume of this thing, it is it is cross-sectional area of the circle, which is pi r squared times the height. So if I ask ourselves, is she able to use a meter rule to find these variables to get the volume of the copper, cylinder? Radius, finding the radius, we can use a meter rule to measure the diameter of that cross-sectional circle, and diameter divided by 2, you're able to get the radius. So she can use a meter rule to get this. She can use the meter rule to find the height. So that is, she can also get the volume of this. She can get the volume of that. Then the steel spanner. Getting the volume of this steel spanner. Now, this steel spanner has some irregular shapes here and there. And so you cannot accurately get the volume of this wheel spanner using a meter rule. So this one is out. Then, of course, the stone tile. Length, you can get the length there, you can get the width, you can get this height using a meter rule. So this is in. So which 3 materials are these? The 3 materials this student was able to measure using the meter rule, and given the known mass are the glass, where there is no steel. Of course, where there is steel, this is out. Where there is steel, this is out, and this is also out. So the answer is B. A stone has a volume of 0.5 centimeters cubed and a mass of 2 grams. What's the density of the stone? This is pretty straightforward. Density is mass over volume. And definitely the mass here is 2 grams. The volume is 0.5. Of course, that is going to give us. So this is 4 grams per centimeters cubed, and the answer is D. A cube of side 2 centimeters is placed on a balance like you're seeing. What is the density of the cube? Density is given by mass over volume. What is the mass? Now, according to our balance, the mass on the balance is 7.2 grams. So here we have 7.2 grams. Divide that by the volume. This is a cube. Side 2 centimeters, meaning that the length, the width, and the height all have 2 centimeters. So it is 2 times 2 times 2. Length times width times height to find the volume. So this is going to become 7.2. Divide that by 2 times 2 is 4. 4 times 2 is 8. And our answer there is going to become 0.9. And the units, this is in grams, this is in centimeters cubed, so meaning it is grams per centimeters cubed. So this is the answer is 0.9. That's A. And finally, a student is told to measure the density of the liquid and also of a large cube of metal. What pieces of equipment are sufficient to be able to make the measurements needed? When you're measuring density, you need mass over volume. What equipment do you need to get mass? What equipment do you need to find volume? That's what we need to look for. So which pieces of equipment are sufficient to be able to make the measurements needed? We need a balance. Yes, the balance will help us to find the mass. The measuring cylinder will help us to find the volume. And the ruler also can help us to find the volume. Yeah, the ruler helps us to measure the volume of the large cube of metal. We have liquid and also large cube of metal. So measuring cylinder helps us to measure the volume of the liquid, and then the ruler can help us to measure the volume of the large cube of metal. And of course, the balance helps us to find the mass of both these two. Our answer here is A, right there. So I would like to make a quick note here though about the units for density. Density is given by mass over volume. Mass is in grams. Divide that by volume, which is in centimeters. So this is why the units for density are written as grams per. This per means like it's grams divided by, this is centimeters cubed by the way. So it's gram divided by centimeters cubed. Now, sometimes this mass can be measured in kilograms. So if it is kilograms, divide that by meters cubed. So it would mean that the units will be in kilograms per meters cubed, like that. Now, sometimes you will find that this grams per centimeters cubed is written as grams per cc. This cc means cubic centimeters. Yeah, it's the same as this. Also, sometimes you'll find that these units are written with that slash avoided. Well, if you've done laws of indices, you realize that this expression, this one here, this expression is the same as saying, this right here. It's the same as saying grams times 1 over centimeters cubed. This is the same as saying grams, then centimeters to the power negative 3. That's why sometimes this can be written as grams, centimeters to the power negative 3. That negative 3 is accounting for this, that slash, that. Same thing here. This kilograms is the same as saying kilograms, multiply that by 1 over meter cubed. And from the law of indices, that is if you have done that topic, this is the same as saying kilograms, then this is the same as m to the power negative 3 if you're to bring this up. That's why this is sometimes written as kilograms meters to the power negative 3. So in other words, it would be wrong for you to write the units like this. If you come and say that kilograms per meters, then you put negative 3, this would be wrong. This is wrong. The right way to write these units is either you're going to say grams per centimeters cubed, or grams centimeters to the power -3. This is the right way to present them. So that's just a quick note about the units for density. And that's it. My name is Arnold Rangakuramia, and thanks for tuning in. Remember to share this video with your friends. I'll catch you in the next session. Take care.